I realize you probably don't have room at the top. So, I don't know if you want to write this on the margins or whatever. I wasn't very happy yesterday with how clear I was on how to tell if something is differentiable. So I thought about it last night as a different way of presenting it to you. I'm partially still just getting used to these notes and how I've normally explained topics. So it's not always directly perfect. So to be differentiable at a single number, I realize this is just a ton of notation in writing. The top set we've already covered, and this is exactly how you have to prove something is continuous. So, like on the test we took, and or whoever's retaking it today, there was a question about continuity. I don't even remember how it was. I think it was during one of the free response ones. To show that something is continuous, you have to show that the limit from the left, from the right, and the function value are all the same. Okay? So if a function is continuous, and the slope on the left, the slope on the right are the same, then that would automatically mean the slope in the middle is those two. So to be differentiable just means, are you able to find a slope answer? All of this has to happen. Now, it generally does, and usually you don't have to find this or prove it. But in this section, that's kind of specifically what all the questions are. So it's very detailed. It looks like people are still writing it down. I'll leave it up there for a second. So these pictures that are right below this, to me, those should be like super immediate fast. You're looking at a picture and you could immediately tell why you can't find the slope. So the first two aren't continuous at a certain number. So the first two pictures don't meet this criteria. I mean, as you're looking at it, it's super obvious. But if you had to prove it, this is how you prove it. The third picture is continuous, so like this works. But the third picture, the slope on the left and the slope on the right are not the same because there's a sharp point. So a sharp point is easy for somebody to spot and say there's not a slope there because it's a point. But if you just have an equation, this is how you have to go about actually proving it. And so you would say the slope on the left and the slope on the right are not equal. And so then that way you cannot find the slope at the location. So to be differentiable, it's gotta be continuous and equal slopes. So from that, we get to number 2. So we've got 2 different piece functions. And it just leaves it blank and open and says, figure out if it's differentiable everywhere. Now, the 2 equations in A, they're both polynomials, so that means they're just like smooth curves or lines. So automatically both equations themselves are continuous on their own. What we don't know is we don't know if the 2 equations meet up. And so if they meet up, they would be continuous. And then if they're continuous, we have to figure out if the slope is the same where they meet up. Because if they meet up, this would be a sharp point, but if they have the same slopes, it would be kind of a smooth transition. So to be differentiable on a piece function, you have to figure out where they meet up if everything is going to work great. A. Charlie. Charlie, calling somebody.
How many desks are in the classroom?
Just calling a person because the numbers aren't going to be right. There's 36 desks now, but I don't remember, 2 of the numbers are missing.
Barbo.
Okay, first thing we need to figure out, is that function continuous? Do the 2 pieces meet up? Do you remember how to go about doing that? No. Okay, well, to figure out if they meet up, we need to figure out if the height of each function is the same height. How do you find the height of a function? Normally. Like, how would you find the height at x equals 1? Yeah, you just put the 1 into the equation, and that would give you the y value. So on these, do they have the same height at 2? Because 2 is where they break apart. So put 2 into each equation. I heard you say no, but we definitely need to know why. Actually, I'll just use limit. What did you get for the 2 answers, basically? So if I put 2 into the equation on the top, which would be the left side, I got 5. I put 2 into the equation on the bottom, which is the right side, I got 6. So we would say it's not continuous. If it's not continuous, automatically it's not differentiable at 2. And so I guess determining, the question was kind of vague, it didn't ask for a specific. We would say it's not differentiable at x equals 2. B. Do you feel like you've got, do the first step in B. I kind of showed you A, so do the first step in B.
First one I got negative 14.
Okay, bottom one is also negative 14. So, starts off great. The line is continuous, which means they meet up. Now we have to figure out if they have the same slope, so it would make like a perfect transition, or are they coming in at different slopes? which would make a sharp point. Or choose somebody for me, please.
Go. A.
Normally, this would be a lot of work to figure out the slopes at each spot. I was very worried this first question, we were gonna have to find the slopes, because that would require us to do both of the slope formulas, which take a while. But this one, they're both straight lines. So what's the slope on the left, what's the slope on the right?
On the left, it is 3,
Perfect,
and on the right, it's 8.
perfect. So, would we say it's differentiable or not?
Nope.
Okay, excellent. These were chosen because we would know the slopes, because they're straight lines. Normally, we wouldn't know the slopes of a curve.
Couldn't we just hypothetically, like, look at it first and see that the slopes aren't the same?
What do we mean by look at it?
Like, look at 3x minus 5 and look at 10 plus 8x and see that 3x is not 8x. And just see that the
Oh, you're
slope-
just saying go right to the slope step.
yeah,
immediately?
like before having to solve.
Sure. I mean, like, if you automatically knew the slopes were different because they're straight lines, you could theoretically skip the continuous step and just say the slopes are different and be done with it.
Okay.
We did that because plugging in -3 really doesn't require any, like, work to write down. So it's kind of somewhat the same, but yes. Normally the equations are gonna be something you're not gonna be able to just know the slopes though.
Mm-hmm.
Like, we're practicing them on straight lines right now, because you guys haven't learned the quick way to find slopes, which is the next section, I believe. I think that's 3.4. And I figured I'd save it until we came back after break. Okay, do you feel like you would be able to do the bottom one on Desmos? I feel like let's try the bottom one on Desmos to see if you guys would be able to do the steps needed to find that answer. And there's a couple different ways to do it. Okay, so I need to scroll. That didn't work very well at all. There we go. And I'll do it along with you if you're not even sure how to do it. There we go. Oh, shoot. You can be like me and forget that you can't type T into Desmos. Mm-mm. Why can't I? Pick somebody other than Drew.
Elise.
My fault. I should have just predicted that one already. At least choose somebody. You get picked every day, so that's. What?
Yeah.
you guys just pick somebody right by you
I
every
pick
time?
somebody-
Over there.
Yeah, I pick her with the brown hair against the wall. Not with the ponytail. What is your name?
Ella.
Okay.
All I was hoping you could do was tell me, how do I find h prime of 0.5 on Desmos? And there's different ways we can do it. Wait, what? Oh, I thought Ella was right, wasn't it? Oh, okay. I thought I got your name wrong and I was just going with it. It's as simple as that. Perfect. Now, in some cases, this isn't super helpful because almost every single calc problem we have does not want a decimal answer. And so sometimes this is good for you just to figure out if you did something right or wrong. Because the decimal isn't, like, for all I know, that slope is like 1/√3 or something like that, right? And Desmos isn't gonna give you the exact slope. I don't think anybody in here has a Inspire calculator, do they? I mean, we rarely use them anymore. I've got 40 of them in there if we ever want to use them. We've got a class set, but they never took off. They created them like 10 years ago, and basically nobody's bought them. So that nothing really happened with them. The colleges don't try to push them on the students or anything. So TI-84s is still somehow the standard. But the reason I bring it up is they have calculus kind of built in them. And you can just type, find the derivative at 0.5, and it will give you the exact answer rather than a decimal. And so there's a reason they're not allowed on certain standardized tests. Like you can't use them on the ACT or SAT, but you can use them on the AP test, because the AP test, they create the questions so that no matter which calculator you have would not be an advantage. So like this type of question would be on the calculator portion, and they would just be expecting a decimal answer. But normally this type of answer isn't great for us because we don't want to round. Like whenever possible, we want an exact answer. But I just wanted to make sure you guys would be able to check this on here. Now, you can actually do piece functions. I've already seen a bunch of students do them on Desmos. Did you guys do piece functions in AP Pre-Calc or something? Is that why a lot of people know how to type them in already? Okay. If you want, at some point, we can go over how to put them in the computer into Desmos so you can check them. Like, it's very easy to tell if something is differentiable on a piece function if you can type it in and look at it. That way you'd know if you did the problem right.
Can we do that now?
I wanted to make sure you guys had enough time to be able to get help on the homework and turn in the quizzes, because only 2 people turned in the quizzes. And that was 100% my fault because I didn't have it open. Say what? Plural?
You said quizzes.
Quizzes.
Yeah, I was wrong.
Okay.
Oh, as in students
Yeah.
Oh.
turn in the quizzes, yeah.
Yeah.
Yeah, not plural for each person. Okay, maybe what I'll do then is I'll plan that for section 4, so that I'll just teach you how to do a couple things on Desmos, maybe once a week we'll try to make sure to do calculator things, so that you guys know how to use them along the way. A lot of it is just self-explanatory, you just type it in exactly how it looks and it works. But there are other things. If you are curious how to do piece functions on your own in Desmos, just Google it, because there is tons and tons of help for Desmos, because a lot of schools use it now. And so if you Google how to do piece functions it'll pop up. Otherwise, Desmos has their own help thing right here that's actually pretty decent. And so you could just type that in, how to do something. Okay, let's